Alright, so this is part 2 of how to make Flappy Bird in Java. So today we're going to start off with making the code for the pipes. And instead of creating a separate class, like going here and clicking new Java class, we're just going to make our class in the main driver program in flappybird.java. You can do this by just doing class and pipes, pipe. And we're going to make int, need x, y, width, and height. And we're going to make a quick constructor. Okay, so this is our constructor finished. We just took the 4 variables we created and basically just setting them. So this .x is referring to the x that we made here, and the x on this side is referring to the values that the user, the values that we're going to input when we're creating a new pipe. So below this class that we've made, we're going to make an array list of pipes. We need something to be able to hold all of our pipes because there's going to be many of them. So we're going to store it. We could either store an array or an array list. And the reason we're doing an array list is because the pipe, there's not a certain number of how many pipes are going to be on the screen, because the pipes are going to be disappearing. So we're going to have to delete them and they're reappearing. So the size will always be changing of the array. That's why we can't use a normal array that has a fixed size, but an array list, the size, there's no fixed size. You can basically set it to whatever you want and it can change. In order to use an array list, you're going to have this import right here, import java.util.arraylist. So make sure you have that there with your other imports. Now we're going to create a method that's going to create all of our pipes. So public void add pipes. We're going to make an integer called gap, which is going to be the gap between each pipe. Set it equal to 150, and then int pipe width, set it to 60. Then we're going to make a variable called top height. And we're going to set it to math.random times 200 plus 50. And the reason we're getting an error right now is because math.random gives double values, meaning gives it with decimal places. And this is an integer, so we have to cast it to an int. Math.random is a function that's already in the normal Java interface, so you don't have to do any imports for it. And basically what this piece of code right here is doing is it generates a random floating point number between 50 inclusive and 250 exclusive. So 50 right here is the minimum, and if you take it with a number inside the parentheses, 200 plus 50 is 250, but it doesn't actually ever go to 250. It always goes a little bit less than it. It's 249.9 or something, right? So math.random by itself goes to 0 to 1. When you multiply by 200, it goes from 0 to 200, and then if you add 50, it scales from 50 to 250 now, because you just added 50 to both values. And then it'll give you answers with decimal place, right? It would be a double. So we cast it to integer, which just truncates off all the decimals, so it's only integer values from 50 to 249. Then we're gonna make another integer called int bottom height. And we're gonna be setting it to the height of the whole panel minus the top height minus the gap. And I'll explain later why we're setting these values specifically. And then since we're using an array list, I'm going to do pipes.add. So we're going to have pipes.add, creating a new pipe. And then in place of the x, we're going to put width. Y would be 0. And then the width would be pipe width. And then top height, because this is going to be the top pipe. For this one, the x position is going to be the width. And then the y is going to be top height plus the gap. And then the width is going to be pipe width. And the height is going to be bottom height, because this is going to be the bottom pipe. All right, so to basically explain all these values, I've opened up Canva here. And this is just an example of what our game could look like. And I just cut it off to make it look like the similar size to our screen. So the gap is the gap between the top pipe and the bottom pipe. It's going to be 150, so that's how much room our player or bird has to move between the pipes. The pipe width is 60, and that's this value right here. It's going to be 60 for all the pipes, because all the pipes are going to be the same width. And then top height, basically we're setting it to random numbers between 50 to 249. And the reason we're doing that is because we don't want the pipes to appear in the same formation every time. So if you see, this one has a much smaller height because it probably got a smaller number, and that leads us into the bottom height. And it's going to take the height, which is height of the screen, which is 400, which is 600. So when it takes the height of the screen, which is 600, basically the pipe would be this big. It would just cover the whole, it would just be as tall as the whole screen. But we're subtracting the top height from it. This part gets chopped off, and we're subtracting the gap. So this part gets chopped off, which leaves us with this much of the bottom pipe. That's exactly how much we want, because we wanted to cover the top pipe, and there's still the 150 gap between, so the player or the bird could pass through. And so the first pipes to add, the first one is going to be the top pipe because we're using top height, and then the second one is going to be the bottom pipe because we're using bottom height. For these, the X values are going to be width because they're going to be spawning off the screen. And the width is 400. So if they spawn, they're going to spawn like off the screen. You won't be able to see them, and then we're going to make them start moving to the left. So they'll slowly show up. And for the first one or the top one, we're setting the Y value to 0. And this is because the pipes are going to be rectangles, and this part of the rectangle is going to be basically how we base what we base our position off of, right? So this part is 0, meaning it's going to spawn in at the top right here. And then the width is going to be pipe width is going to be the same. And then top height is obviously going to be random. Look, it could be like this big, or it could be this big, or this big. So it's going to just really depend on what number you get. And then for the bottom pipe, we're taking the top height's height. So this is the top height, and we're adding the gap, which should be 150 here. So the Y value is going to start right here, and then it's going to build itself down. And then, because that's like the top corner, that's where the positioning of the rectangle happens in Java based off the top corner. Top corner would be right here. And then the pipe width is obviously going to be the same. And then the bottom height is calculating using this formula. I'll just fill the rest of the screen and make the pipes appear properly. And while we're at it, we can change this from public to private, because it won't make a difference in our code. It's just good coding practices, because there's no reason for it being public, because no other class is going to use it. So we can just keep it private. So now we can begin drawing the pipes. For the pipes, we're going to set the color to green. And then we're going to use a for each. Inside the for each loop, for every pipe called P in the array list pipes, we're going to fill the rectangle with P dot, and then we're using the respective variable name. So this is the X, this is the Y, width, and height. Okay, so now that we have the drawing part out, you can run the program, but you're not going to see the pipes yet because we've had them positioned off the screen, like off to this side. You're only going to see them once we make them start moving. So let's just code that part now. So let's go back to the action performed. And then this is the bird physics part. Now we can just add the code for removing the pipes. Just copy this because we're going to use another for each loop. And then change this to p.x minus equals 4. So it's taking the P, so the current pipe that we're on, it's taking its X value and it's decreasing it by 4. Okay, so now that we have the code for moving the pipes, we can add the code for removing old pipes, the ones that go off the left side of the screen. Removing old pipes and adding new ones. We're going to need an if condition. So this is our if statement for removing the old pipes and adding new ones. If the first pipe, because we're using 0 as our index, so it's like the first one in the array list, if its X value plus its width is less than 0, so X value would be right here, and then width would be this whole thing. That means the point it's referring to is this point right here. So when this is less than 0, for this to be less than 0, that point has to appear behind like the frame or the screen, because this right here is 0, 0. So once it's like less than 0, once it's behind the frame that you can see, then we can remove both the top pipe and the bottom pipe. Because if you go to our code, when we're adding the pipes, this is the top pipe, this is the bottom pipe. So the first one at index 0 is top, and then index 1 is bottom, and it just keeps repeating like that. That's why we have removed twice. So this removes the pipe at index 0, the top pipe. So the bottom pipe, which was at index 1, now shifts to 0 since the top pipe has been removed. So you have to remove that one as well. So that's why we do pipes are removed at index 0 twice. And then once we removed it, we can call add pipes, which will just add those like another pair back again. To test our code, go right here in the public Flappy Bird, and we can just call add pipes and then run the program to see what happens. As you can see, a pipe appears on screen, and as soon as it vanishes, another one appears, and the positioning of the pipe is completely random, so it's not the same every time. So now it's all the way up here, and this different one is shifted slightly down, and they're all moving at the same speed. They're pretty slow. But yeah, that's it for part 2 of how to make Flappy Bird in Java. All we did in this part was add the pipes.